Welcome back. Today I'll discuss piecewise function. What is a piecewise function? It is a function defined by more than one expression on a sequence of intervals. If you see a function that looks like this, then it is a piecewise function. You see, we have two functions combined to be a single function. This line is defined by one expression, and then the other line is defined by another. And then this is the sequence of intervals that I'm talking about. One interval, and then another. We have the first interval on the line going downwards and to the left all the way. And we have x less than 0 on that interval, or in interval notation, that's in between negative infinity and 0, which is actually referring to the left side of the y-axis. And on the other interval, that's x greater than or equal to 0, because the other line goes all the way to the right, starting from the y-axis. Or in interval notation, this is from 0, we use brackets, to positive infinity, just because the line is going all the way to the right. Now, in sketching the graph of a piecewise function, it is always important to look at these intervals, because that's how you'll know where to sketch the graph of the function. Sketching the graph of a piecewise function, just like this one, is easy. It's just like sketching the graph of a normal function, which we usually write in this form. But as I said, piecewise functions always have a sequence of intervals, which are actually conditions in sketching its graph. So the piecewise function over here is not complete without the conditions. We can have if x is less than 0, and then if x is greater than or equal to 0. That's one way of writing the conditions of a piecewise function. To sketch its graph, we actually have two functions combined to be just one. So we have to sketch the graph of y equals f of x separate from the function y equals g of x. Y equals g of x. Y equals f of x, we consider that if x is less than 0, and then we consider the other function if x is greater than or equal to 0. So you see, we'll be seeing the first function. Let's call this function a. We'll be seeing function a on the left side of the y-axis, and we'll be seeing function b on the right side of the y-axis and on the y-axis itself, because of this inequality symbol. To explain better, let me give you an example. So this one is an example of a piecewise function defined by two expressions. One is 2x plus 3, and the other one is a constant 5. So we have f of x is equal to 2x plus 3 if x is in between negative 3 and 1. And then f of x is equal to this constant, 5. Let me use another color for that. F of x is equal to the constant 5 if x is greater than 1 or equal to 1 but less than 5. I'll call the first one function a, and then the second one function b. We'll draw function a separate from function b, but we have to consider the conditions. You should be able to identify that function a is a linear function so that it will be easier for you to sketch its graph. So if it's a linear function, therefore it will give us a line when we draw it. Therefore, we only need 2 points on that function, and then connect those 2 points to draw the line. So look at the condition. This condition if x is in between negative 3 and 1. So where is negative 3 and 1 on the x-axis on the Cartesian plane? Negative 3 is here, and then positive 1 is here. So we'll just have to consider the function a, whenever we have these numbers on the x-axis, including all the numbers in between. Now, how do we get 2 points on that line? So we're in function a first. We just have to take numbers in between negative 3 and 1. Or actually, we can take these endpoints, negative 3 and 1. Okay, we just have to remember that negative 3 and 1 is not included in that interval because we have strictly less than inequality symbols. Okay, so whenever x is equal to negative 3 in that function, in the first function, we're talking about function a, what is the value of the function? What is the value of f whenever x is equal to negative 3? We just have to substitute negative 3 for every x in function a. So that's 2 times negative 3 plus 3. Okay. We have, that's a negative 6 plus 3. And that's equal to negative 3. So whenever x is equal to negative 3, the function is equal to negative 3 as well. So we have the point negative 3, negative 3, just because whenever x is negative 3, the value of the function is negative 3. So the point here on our Cartesian plane lies here. But take note that negative 3 is not included in our interval, in the condition, okay, here. So therefore, instead of using a shaded circle, we won't be using a shaded circle, but instead, just to indicate in the graph that negative 3 is not included in the condition, we'll be using an empty circle, unshaded, like that. Okay. Now we take the other end point. Whenever x is equal to 1, okay, what's the value of f? F of 1, again, we have to substitute 1 for every x in function a. That's 2 times 1 plus 3, and that's going to give us 5, right? So f of 1 is 5. So whenever x is 1, the value of f is 5. Therefore, we have the point with the coordinates 1, 5. And where is that point? It's here. Again, we'll be using empty circles just because 1 is not included in the sequence in the first condition. I mean, in the interval in the first condition. Now we have 2 points that we can connect to draw the line. Connect. There you have the line. It's just actually a line segment because of the interval from in between negative 3 to 1. But its equation nonetheless is f of x equals 2x plus 3. Okay, now in function b is not very difficult to sketch because it's a constant function. If it's a constant function, you'll always be getting a horizontal line. Because the value of the function is always 5. Look at this. The value of the function is always 5 whenever x is greater than or equal to 1. Okay, in this interval. And is less than 5. So in our graph, look at the graph. 1 is here, and then 5 is here. So in between these numbers on the x-axis, the value of the function is always 5. But take note that on the second interval, 5 is not included. So instead of using a shaded circle on the number 5 in the graph, we'll be using empty circles. Okay, empty circle here. Oops, yellow is not good. There. Now, as I've said, the second function, function b, is actually a horizontal line the value of the function is always 5. This is 5 on the y-axis. Okay, so we'll have a line, horizontal line, from x equals 1, this is x equals 1, okay, up to x equals 5, but 5 is not included in the interval. But take note that 1 is included in the second interval, so therefore, instead of having an empty circle over here, look at this, now this will be shaded. I'll use yellow. This will be shaded because of the second function and because of the second interval. This second interval includes 1. So therefore, in that horizontal line, 1 is included. Alright, so in function B, whatever the number is on the x-axis, so when x is equal to 1, let's say, f of 1 is 5, because it's a constant function. When x is equal to 5, take that number, f of 5 is still equal to 5 because it's a constant function. Actually, if you take any number in the interval from 1 to 5, let's say if x is equal to 2, f of 2 is still equal to 5, just because function b is a constant function. Therefore, we'll have this horizontal line. Alright? Now, what about the domain and range? Domain and range. To identify the domain and range, we simply have to look at the function or the graph of the function. Okay? To identify its domain, we just have to look at how far it goes. How far does the graph go with respect to the x-axis? In this case, with respect to the x-axis, we have, look at this, we start from -3 here and then end at 5. But then, on the x-axis, because of this empty circle and this empty circle, we know that those 2 points are not included in the graph. Okay, therefore, as we start from -3 and then at +5 on the graph, okay, with respect to the x-axis, -3 and 5 are actually not included in the graph. So, in the interval notation in the domain, instead of using brackets, we'll be using parentheses. So as far as the x-axis is concerned, the graph starts at 3 or -3 and then ends at 5, where -3 and 5 are both not included. Okay, so therefore the domain is in between -3 and 5. Now for the range, we have to look at how far the graph goes with respect to the y-axis. Okay, it goes as far as -3 down below here and as far as +5 above. But again, this point is not included in the graph. Therefore, the lowest point on the graph happens at y equals -3, but that point is not included. So just to indicate that -3 is not included in the range, we'll just have to make use of a parenthesis in the interval notation in the range. Okay, so -3 is the lowest number on the y-axis, and then the highest number is 5. But this time, 5 is included because of this point, not just that point, all the points on this line. Okay? So therefore, we include that number on the range. That is the range of the function. So there you have it, the graph of the function and its domain and range. Another example on piecewise functions. Again, we have to sketch its graph and then afterwards determine its domain and range using the graph. Okay, so we have two expressions again defining the function. Let's have the first function, f of x equals x squared. As you may now be familiar with this is a quadratic function that will give us a parabola opening upward with vertex at the origin. So if x is greater than 1 but less than or equal to 2, and then we have another function using another color. F of x is again a constant function equal to 3. That will give us a horizontal line elsewhere. Now this is not very clear. Okay, elsewhere means that whenever we have numbers that are not this on the x-axis, okay, that's what we're talking about in the term elsewhere. Now let's sketch the graph of this function a. We'll call this function a, and then the other function b. Okay, sketching the graph of function a. Again, we'll just get at least two numbers on the x-axis and then get the corresponding value of the function at those particular numbers. Let's say when x is equal to, let's just use the endpoints 1 and 2. When x is equal to 1, what is the value of the function? F of 1 is equal to 1 squared, which is 1. Therefore, whenever x is 1, the value of the function is 1, we have the point 1, 1. Okay? Since 1 is not included in this interval, so in the graph, instead of using shaded circle, we'll be using empty circle to indicate the point 1, 1 on the graph. There you have it. This is not a line, remember? Not a line, but a part of a parabola actually, just a part of it. And then, in that same function, when x is equal to 2, that's the value of the function. F of 2 is equal to 2 squared, which is 4. And fortunately, 2 is included in the first interval, therefore, so the point 2, 4, with coordinates 2, 4, is included in the graph. So we'll be using shaded circle. This is not a line, again. This is actually a portion of a parabola. The parabola goes like this. It goes like this. Goes all the way up. But we will not be including the whole parabola, but just a portion of it because of this interval. So just a portion of the parabola in between those 2 points that we have drawn. It will be like that somehow. Okay, so that is the graph of the first function. Now in the second function, sorry about that, let me redraw. Okay, in the second function, function b, it's a constant function. The function is always equal to 3 elsewhere. So that will be here on the right side of 2, elsewhere, aside from x in between 1 and 2 and equal to 2. So that will be on the right side of 2 and on the left side of negative 1. The function is always the constant 3. Alright? So when we say the function is a constant function equal to 3, so the function is always equal to 3 on x greater than 2 and x less than or equal to 1. Wait, let me just redraw the first function. Okay, just to make it clearer. 3. Okay, this is function b. Okay, 3 elsewhere. So constant function goes all the way to the left. And then here, oops, this should be an empty circle, not shaded. Empty circle, not shaded, all the way to the right. And then this must be shaded on the other side. There you have it. Okay, why was the other circle shaded and the other one empty? Okay. Elsewhere means the complement of this. So we have this in between 1 and 2 and equal to 2. The complement of that would be x greater than 2 and x less than or equal to 1. This is what we call elsewhere. These are the numbers not included in the first interval. You follow? Because 2 is already included in the first interval, we don't want to include 2 in the second interval anymore. And because all the numbers greater than 2 are not included in the first interval, therefore we have to include all the numbers greater than 2 in the second interval, in that elsewhere. Okay? Elsewhere. Now, because 1 over here, look at this, is not included in the first interval, therefore in the second interval, we have to include 1. Hence, shaded here, and not shaded in the second point. Okay? So that is what we mean by elsewhere. Now about the domain and range of the function. Domain and range. So how far, for the domain, how far does the graph go with respect to the x-axis? Okay, as you can see, the lines go all the way to the right and to the left. Therefore covering all the numbers on the left side and the right side of the y-axis. Okay? And then this graph, that portion of the parabola actually covers all the numbers in between 1 up to 2. Okay, in between 1 and 2, including 2. So it covers all the numbers as far as the x-axis is concerned. So therefore, the domain of the function is the set of real numbers. So in interval notation, that would be from negative infinity to positive infinity. Now, how far does the graph go with respect to the y-axis? That would be the range. Look at the lowest point on the graph and then the highest point on the graph. This is the lowest point on the graph, happens here. Okay, this is the lowest point at y equals 1. Alright, let me be clear on that. Y equals 1. And then the highest point, it is at y equals 4. But at y equals 1, we have an empty circle. That empty circle over there. So which means to say that 1 is not included in the range of the function. But this is a shaded circle, meaning it's included in the range of the function. So the lowest point happens at y equals 1, but 1 is not included. So we use parentheses. And then the highest point happens at y equals 4, but 4 is included in the range just because we have a shaded circle over there at that portion of the graph. So there you have it, the graph of the function and its domain and range.